Okay, we're going to finish up our inverse notes, okay? And then we are going to practice. So, yesterday we were reading a situation and then we were asked to determine what each thing represented, okay? So right here, it tells me in my instructions, it says, suppose W equals P of X is the average daily quantity of water in gallons required by a palm tree with a height of X feet. So the palm tree's height for X. Bless you. Okay? All right, so right here, if I'm looking at part A, what would P of 25 represent? First of all, I'm going to come up here and look at the format, P of X. So the number inside right here represents X. What did X represent? The height of the tree. All right, and then the whole thing, when I put that in, plug it out, and work it up, that number represents the average daily quantity of water required, okay? So P of 25 means that the average daily water, or this represents the average daily water needed or required for a 25-foot palm tree. It is a tall palm tree. I've never seen one that tall, I don't think. I guess unless you like out in LA. Well, they're all burnt now. Yeah, golly.
Yeah, that was kind of bad timing.
I know. Yeah, I didn't intend for that to come out and be mean.
What?
Oh, yeah, I forgot about that.
Okay, all right, now, right here, this says, what does the expression P inverse of 25 represent? Now remember, with the inverse, you take the X and the Y and you swap them. So, what does the 25 represent this time? The average water needed, right? And then the output is going to be the height, okay? So, right here, this represents the height of a palm tree that requires 25 gallons of high quality H2O. All right, C says, what does the equation P of V equals 50 tell you about V? All right, notice that the variable changed. Does the variable itself really matter?
No.
No, its placement does. Okay, so what is V representing here? Go back up to your notes. I just swapped the V in for an X, I swapped.
The water?
Nope,
The height of the tree.
it's the height of the tree.
It doesn't have the minus.
Wait, what? Oh.
All I changed was this V right here inside. Okay, so that represents the height of the palm tree. Okay, and then it says rewrite this equation in terms of P inverse. So right here, I'm going to say P inverse of 50 equals V. All right, once again, down here in part D, I changed the variables out. It says palm trees are on average Z feet high, and a tree height requires K gallons of water. Represent this in terms of P and P inverse. So I've got to use my new variables, okay? For my original function, what was I substituting? P of x, right? So which here represents the height? Z. So here I'm going to say P of Z equals K. And then for the inverse, I'm going to take those variables and I'm going to swap them. So what does that give me?
P and K.
P inverse K is easy.
Perfect. Okay? All right, we're going to drop down to the very bottom of page 19 and we're going to look at these tables. Okay? All right, I am given function f of x and I'm given function g of x. And I'm asked to evaluate each one of these things, okay? Now, for an inverse, okay? For an inverse, what have I done with my x and my y? I have swapped them. So right here, this is not the x value, but I'm looking for a y value of -4 for function f, or f inverse, okay? So right here, I'm going to come and I'm going to find the -4. And what do you think my output is going to be? 5, the x value. Okay? All right, now I'm asked to find g inverse of 6. So once again, if it's the inverse, this represents the y coordinate. So what is g inverse of 6? 8. Okay? All right, now this one looks a little different. C and D look a little different because it's a composition. So when we do a composition, we're always going to start with the innermost function. Okay? What is g of 1, and what does 1 represent? That's my x value, yeah, because that's not the inverse. So g of 1, I'm going to come find 1, and the output is -3. So that is what I'm going to use to calculate f inverse of -3. Now, because this is the inverse, what does the -3 have to represent?
Y.
The y value, okay? So the output here is going to be +3. Okay? So I'm going to start with my innermost function right here. This number inside, just like the last one, represented the x, or it represents the x. So what is f of 0? -1, okay? And then I'm going to do g inverse of -1. The -1 now represents the y value because that's the inverse, okay? So the inverse, or the g inverse of -1 is 4. The end. The signs and whether it's an inverse or not an inverse is going to be the tricky part. Okay? All right, friends, flip it over. All right, let's talk about rational functions for a little bit. I feel like this is one of those things where you want to avoid the fractions at all costs, but they don't go away. So, all right, the following rational function is 1-to-1. So that means it passes the horizontal and the vertical line test, okay? So here's my original function, function f of x. All right, I'm going to color code this real quick. And I am asked to find its inverse. Find its inverse. To calculate an inverse, this is where I swap the x and the y in my equation. How many x's do I have? I have 2 different x's. I have to replace both of them with y, okay? So I'm going to say x equals 2y plus 3, and then y plus 2. All right, now as this is, you cannot divide these two and get anything pretty, okay? This whole thing is the numerator, this whole thing's the denominator. we cannot break it up, okay? So in order to get rid of division by w plus 2, I'm going to multiply both sides of my equation by w plus 2. It is okay to multiply, not, that is clearly a y, I'm so sorry. I'm telling y'all, my brain is not right today. Y'all should hear me trying to call my children's names at home. I've even started throwing the dogs' names in there.
Yeah, I was like, I gotta call the dog.
Oh, man. Okay. All right, now, the denominator canceled out. So I'm going to rearrange this. X times y plus 2 equals 2y plus 3. All right. I am going to distribute the x. So this is xy plus 2x is equal to 2y plus 3. My job is to solve for y. So I need to put the y's on the same side to see if maybe I can reduce it somehow, okay?
Divided by what?
No, because then I'll create more fractions. Watch this. I'm going to move this xy over to this side, and I'm going to move this 3 over here just to get it out of the way, okay? So this gives me 2x plus 3, and I now have 2y minus xy.
That is minus 3. Yeah.
Wouldn't it be minus 3 because you?
Yes, I'm sorry. God bless America.
Jamie, stop.
I'm just doing it to see if you're paying attention.
Oh, yeah.
Not really. Not really. Okay, what do you see on the right-hand side? You cannot combine anything here. What do you see on the right-hand side? They both have a y, so therefore what could I do?
Factory.
I could factor out a GCF. So I got 2x minus 3. If I factor out a y, that leaves me with 2 minus x inside.
Yes.
In the point to get y by itself, and y is being multiplied by something,
So you can take out
so what can I do to get rid of multiplication? Divide. I'm going to divide both sides by 2 minus x.
Then you can have the negative.
I'm okay leaving it just like it is.
I was trying to go the extra.
You're right. Okay, so I'm going to say y equals 2x minus 3 over 2 minus x. I'm then going to go so far as to show I'm changing my notation back. This is f inverse of x, and it is this rational function 2x minus 3 over 2 minus x. Okay? All right, do me a favor. It says find the domain in the range of f of x. Is that the one I just found, or is that my given equation? It's my given. So all I'm asked to do is find the domain in the range of f of x. That's my original function, okay? The domain is affected by excluded values, okay? So if I'm looking at my original function, the excluded values are what would make my denominator equal to 0. What is x not allowed to equal?
Negative 2.
-2. Very good. Okay, so that makes the domain negative infinity to -2 and -2 to positive infinity. Okay? Now, the range of rational functions are affected by horizontal asymptotes and holes. Last semester stuff coming back. Okay, now horizontal asymptotes. All right, that comes from the BoboBots Eats DC. Okay, I'll go ahead and write that. BoboBots Eats DC. Okay? Now, for my original function, was I able to factor anything out and cancel anything out? From the original function, is there a GCF or anything that I could remove from the numerator that would give me the same thing on top and bottom? No. Nothing cancels, so there's no holes. Okay? So all I need to worry about is horizontal asymptotes. That's where we go and we compare the exponents. Okay, I have 2 times x, that's to the first power, and then down in the bottom, the highest thing has a first power. So first power. How do those exponents compare?
They're the same.
They're the same. Exponents are the same. We will divide our coefficients. Coefficients here, 2 divided by 1. So here, y cannot equal 2. So that makes my range negative infinity to 2 and from 2 to infinity. Okay? All right. If a function is not one-to-one, then its inverse is not a function. However, if an appropriate restriction on the domain is made, then we can find an inverse that is also a function. So do y'all remember yesterday we had graphed something? We had the square root function on our graph, but then we graphed its inverse and it was the whole parabola. I had to cut off half of that parabola. That's what I'm saying we can do here, okay? So the very first thing that I am asked to do is to find the inverse of this function, 2 minus x squared. So to find the inverse, I'm going to swap the x and the y. Also affectionately known as w. If you can't make fun of yourself, what can you do? Okay? All right, now, I want to start getting everything away from the y, okay? This is a positive 2 that I want to move over here. So if I have a positive 2, on the other side, it's going to be negative. Next thing I want to do is get rid of the negative. So I'm going to divide both sides by negative 1. This negative 1 I can divide into x and to negative 2. So that's just going to change the signs there. And then how do I get rid of a square? A square root. Okay? So I'm going to say y equals, or better yet, I'm going to call this f inverse of x equals. All right? One other little fun fact. Technically, when you take the square root, you have to put a plus or minus out front. Okay? But I don't want both of them here. I want just the positive. Okay? All right. Grab a graphing calculator. Okay, I'm asked to graph both f and its inverse. So I'm going to start by graphing my original function. But I want you to pay attention to the domain restriction. Type this in y equals and then go to your table. 2 minus x squared. and then go to second graph, and go to where x is 0. What do you get out? 2. Okay? All right, now, x is greater than 0. I'm going to move to the right as I'm plotting. What's the output for 1? 1. All right, what about the output for 2? -2. What about the output for 3? Okay, it's going to be somewhere down here. Okay? So I'm going to I'm going to sketch this function. This is function f of x. Okay? Now, just as a reminder, all of our inverse functions are technically a reflection over the line y equals x. Okay? So what was this first ordered pair that I did? It was 0, 2. So my inverse should have an ordered pair of 2, 0. I had 1, 1. That's going to be the same. Then I had 2, -2. So that's going to be -2, +2. And then it was what? 3, -7? So -7, 3. Somewhere up here. This is graph f inverse of x. Now, if I were asked to find the domain here, okay, what I would want to do is I could look at my graph and I could say, okay, well, this graph is everything 2 and smaller, okay? It goes that way. Another way that we can do this, okay, in order to find the domain, especially of a radical function, we know that everything that's underneath the radical has to be greater than or equal to 0. Okay? I'm going to make a note that this is the domain. Even though I'm not asked to find that, I'm sure you will be at some point. So I want to solve for x. How do I start? Get x by itself. Which way do you want to do this?
Subtract.
Just subtract 2? Okay. All right. So that's going to give me -x is greater than or equal to -2. And then when I divide by -1, what happens?
It cancels out.
The negative is canceled out, but there's something that you have to do with your sign.
Switch it. Watch, switch it. Yeah.
See? Y'all are saying it like I did the other day. You're going to swip it. You're going to reverse it. Okay? So any number that you plug in for x has to be 2 or smaller. Otherwise, if you plug in something bigger than 2, for example, if I plugged in 4, that would be -4 plus 2, which is going to be a negative radicand, okay? We don't want that. All right? Down here at the bottom, it says, suppose f of x and g of x are one-to-one functions. You're told if f of 3 equals 5, that means you have the ordered pair 3, 5, and g of x has the ordered pair 5, -2, can you determine whether these functions are inverses of each other? Explain why or why not. What happens when you're doing the inverse? What have I been doing with my ordered pairs? Switching them, right? So the inverse of f of x would have the ordered pair what? 5, 3. You can't have a 5, -2 and a 5, 3. So what are we going to say?
They do not.
They are not inverses. F of x f inverse of x should have the ordered pair 5, 3, not 5, -2. Okay? Questions? Okay. All right. Now you're going to practice. So keep your notes out so you have that as a reference. You're not going to do all the problems. So when I give you your practice, wait to hear which ones I assign.